The Kelvin is a unit of measure for temperature based upon an absolute scale. It is one of the 7 base units in the International System of Units and is assigned the unit symbol K. The Kelvin scale is an absolute thermodynamic temperature scale using as its null point absolute zero, the temperature at which all thermal motion ceases in the classical description of thermodynamics. The Kelvin is defined as the fraction 1/273.16 of the thermodynamic temperature of the triple point of water. In other words, it is defined such that the triple point of water is exactly 273.16 K. The Kelvin scale is named after the Belfast-born, Glasgow University engineer and physicist William Lord Kelvin, who wrote of the need for an absolute thermometric scale. Unlike the degree Fahrenheit and degree Celsius, the Kelvin is not referred to or typeset as a degree. The Kelvin is the primary unit of temperature measurement in the physical sciences, but is often used in conjunction with the Celsius degree, which has the same magnitude. Subtracting 273.16 K from the temperature of the triple point of water makes absolute zero equivalent to minus 273.15 degrees Celsius. History. In 1848, Lord Kelvin wrote in his paper, On an Absolute Thermometric Scale, of the need for a scale whereby infinite cold was the scale's null point, and which used the degree Celsius for its unit increment. Kelvin calculated that absolute zero was equivalent to minus 273 degrees Celsius on the air thermometers of the time. This absolute scale is known today as the Kelvin thermodynamic temperature scale. Kelvin's value of minus 273 was the negative reciprocal of 0.00366, the accepted expansion coefficient of gas per degree Celsius relative to the ice point, giving a remarkable consistency to the currently accepted value. In 1954, the Resolution 3 of the 10th CGPM gave the Kelvin scale its modern definition by designating the triple point of water as its second defining point, and assigned its temperature to exactly 273.16 kelvins. In 1967–1968 Resolution 3 of the 13th CGPM renamed the unit increment to thermodynamic temperature Kelvin, symbol K, replacing degree Kelvin, symbol degree K. Furthermore, feeling it useful to more explicitly define the magnitude of the unit increment, the 13th CGPM also held in Resolution 4 that the Kelvin unit of thermodynamic temperature is equal to the fraction 1/273.16 of the thermodynamic temperature of the triple point of water. In 2005, the Comité International des Poids et Mesures, a committee of the CGPM, affirmed that for the purposes of delineating the temperature of the triple point of water, the definition of the Kelvin thermodynamic temperature scale would refer to water having an isotopic composition specified as VSMOW. Usage conventions. When spelled out or spoken, the unit is pluralized using the same grammatical rules as for other SI units such as the volt or ohm. When reference is made to the Kelvin scale, the word Kelvin, which is normally a noun, functions adjectively to modify the noun scale, and is capitalized. As with most other SI unit symbols, there is a space between the numeric value and the Kelvin symbol. Before the 13th General Conference on Weights and Measures in 1967–1968, the unit Kelvin was called a degree, the same as with the other temperature scales at the time. It was distinguished from the other scales with either the adjective suffix Kelvin or with absolute, and its symbol was degree K. The latter, which was the unit's official name from 1948 until 1954, was rather ambiguous since it could also be interpreted as referring to the Rankine scale. Before the 13th CGPM, the plural form was degrees absolute. The 13th CGPM changed the unit name to simply Kelvin. The omission of degree indicates that it is not relative to an arbitrary reference point like the Celsius and Fahrenheit scales, but rather an absolute unit of measure which can be manipulated algebraically. Used in conjunction with Celsius in science and engineering, degrees Celsius and kelvins are often used simultaneously in the same article. This practice is permissible because the degree Celsius is a special name for the Kelvin for use in expressing Celsius temperatures, and the magnitude of the degree Celsius is exactly equal to that of the Kelvin. Notwithstanding that the official endorsement provided by Resolution 3 of the 13th CGPM states, a temperature interval may also be expressed in degrees Celsius. The practice of simultaneously using both degree C and K remains widespread throughout the scientific world, as the use of SI prefixed forms of the degree Celsius to express a temperature interval has not been widely adopted. Proposed redefinition. In 2005, the CIPM embarked on a program to redefine, amongst others, the Kelvin using a more rigorous basis than was in use. The current definition is unsatisfactory for temperatures below 20 K and above 700,313,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000, which Boltzmann's constant is 69771380650499999991.38065005 times 10⁻23 J K. Exactly. The committee hoped that the program would be completed in time for its adoption by the CGPM at its 2011 meeting. But at the 2011 meeting the decision was postponed to the 2014 meeting, when it would be considered as part of a larger program. From a scientific point of view, this will link temperature to the rest of SI and result in a stable definition that is independent of any particular substance. From a practical point of view, the redefinition will pass unnoticed. Water will still freeze at 0 degrees Celsius. Practical uses. Color temperature. The Kelvin is often used in the measure of the color temperature of light sources. Color temperature is based upon the principle that a black body radiator emits light whose color depends on the temperature of the radiator. Black bodies with temperatures below about 700344000 K appear reddish, whereas those above about 7003500007500 K appear bluish. Color temperature is important in the fields of image projection and photography, where a color temperature of approximately 70035600000005600 K is required to match daylight film emulsions. In astronomy, the stellar classification of stars and the place on the Hertzsprung-Russell diagram are based, in part, upon their surface temperature, known as effective temperature. The photosphere of the Sun, for instance, has an effective temperature of 7003577800000005778 K. Digital cameras and photographic software often use color temperature in K in edit and setup menus. The simple guide is that the higher the color temperature in K, then the more white or blue the image will be. The reduction in Kelvin will give an image more dominated by reddish, warmer colors. Kelvin as a measure of noise in electronics. The Kelvin is used as an indicator of how noisy a circuit is in relation to an ultimate noise floor, i.e., the noise temperature. The so-called Johnson-Nyquist noise of discrete resistors and capacitors is a type of thermal noise derived from the Boltzmann constant and can be used to determine the noise temperature of a circuit using the Friese formulas for noise. Unicode character. The symbol is encoded in Unicode at code point U plus 212 AK Kelvin sign. However, this is a compatibility character provided for compatibility with legacy encodings. The Unicode standard recommends using U+0004B Chi Latin capital letter K instead, that is, a normal capital K. Three-letter-like symbols have been given canonical equivalents to regular letters. U plus 2126 ohms ohm sign, U plus 212 AK Kelvin sign, and U plus 212 BA angstrom sign.